Okay, so stoichiometry. This chapter is an interesting chapter because it goes from everything we've learned so far and then just adds one tiny little thing. And that's why today we'll finish about 90% of the chapter, because it's just one little addition to everything we've learned before. So we're going to do mole conversions. We're going to do little equations where we're balancing things. We're going to do a little nomenclature. Everything's in here, all right? But with that one little addition, that's it. That's all stoichiometry really is. So it's based on those equations that we learned how to do, and it deals with the ratios between the reactants and the products. So the idea here is you're starting with some reactants. How much product can you actually make, all right? And this is an exciting chapter because this is what real chemists do. They start out with some ingredients, reactants, and then they make some products. And with this chapter, we'll be able to calculate not only like what products are produced, but how much are produced, what runs out of the reactants, okay? So let's go through a couple scenarios. And the first thing is, let's pretend we're gonna make some cookies, all right? So we have the Nestle Toll House recipe. I'm not getting paid for this. I wonder if I can post it on YouTube. I don't know, it's a free commercial for them, I guess. I don't know. This is how you make the cookies. If you combine all of these ingredients in the correct order and then bake it, you'll get some cookies, right? How many cookies?
60.
You'll get 60, exactly. So you'll get 60 chocolate chip cookies and everything will be great, right? You can do that, right? Potentially. That's all stoichiometry is, all right? So let's continue. Let's pretend we take the magic school bus to ShopRite and we bought at least double of everything we needed besides butter, since we know there's a big thing of butter in Mr. O'Neill's refrigerator, all right? So he's got all this butter. We know it's there. We get back to school though, and then we found out Mr. O'Neill ate all the butter. There's only one stick of butter left over, all right? So if there's only one stick of butter, how many cookies can we make? I don't know if with one stick of butter we can still make 60, right? We could only make 30, right? Or you could make 60 tiny cookies, I guess, but that's where they're changing things here, right? We could make 30 because we would only have half of this, but we had more than enough of everything else, right? Okay, that makes sense, right? It's the whole ratio thing. All right. Now, just like in some movies and TV shows, let's pretend that we're in the multiverse, all right? There's alternative timelines to everything, all right? So that was one timeline. We get back to school and there's one stick of butter. Alternative timeline, we get back to school and we have 4 sticks of butter, all right? Now we have 4. How many cookies can we make with those 4 sticks?
120.
Yeah, exactly. 120, because we only needed 2, and we had at least double of everything else, right? So then we can make 120 cookies. All right, is everybody cool with that? What limited the amount of cookies we could make? The butter, right? The butter was our limiting ingredient, right? Or a limiting reactant, all right? So in stoichiometry, it's the same thing. Something is going to run out first, whether it's butter or oxygen. It's all the same ideas. Once something runs out, you can't make any more cookies, all right? Okay, cool. Okay, so what goes here? The number of cookies you can make. Cookies are going to be the what? If we're using chemical terms. The product, good. Cookies are the product. And then it depends on your ingredients. What are our ingredients?
Yeah.
The reactants, good, yeah, exactly. And this chapter works the same way, only it doesn't taste quite as good. Ah, that's where you laugh. So with this one, we're going to talk about ratios here and talk about why the equations are important, all right? First of all, we saw this equation last chapter. To balance it, what do we need to do? What do we need? How many aluminums?
2.
2. How many bromines?
3.
And And then how many of the product? Aluminum bromide? Yeah, 1, okay. All right, so we balanced our equation, right? And we're making, if we do this, 1 of the aluminum bromides, right? We're making 1 aluminum bromide. How could we make double the aluminum bromide? What would we need? Yeah, we would need 4 aluminum, and then we'd need 3 of the bromine, and that would give us 2 of the aluminum bromide, right? Everybody's cool with that, right? We're just doing the ratios here, yeah? Now, remember when we talked about moles, and a mole is what number? 6.02 times 10 to the 23rd, right? It's a big number. Well, we're going to use those in this chapter as well, because only 2 atoms of aluminum, it's a really small amount. But a mole of aluminum, that's something tangible. That's something we could actually hold in our hands, right? That's something we could actually use. So we're going to use moles in the same way here. And we're going to use the same ratios as well. So if this was 2 atoms, we're going to say, okay, it's 2 moles of aluminum, which means you need 3 moles of the bromine gas, and then you'll get 1 mole of aluminum bromide. Much more, and something we could actually use in the lab, right? So that's how we're going to connect this with the mole chapter as well. Okay, so how do we get moles of it? Well, we use those ratios, just like I was saying a second ago. All right, keep the ratios the same. So we would have 2 moles of aluminum, 3 moles of the bromine, and then you'll get 1 mole of your aluminum bromide. All right, is everybody cool with that? Yeah, we're just talking about stuff we've done kind of before. Okay, so now, let's say you have 8 moles of aluminum. How much aluminum bromide would be produced? So again, remember this was a 2, this was a 3, and then this was a 1. Now we have 8 of these aluminums. All right, how much aluminum bromide could we produce? What are you trying to do in your head? Figure out the what? The ratio between them, right? Trying to figure out the ratio between them, right? So if we just doubled it, that would be 4, 6, and 2, right? And then if we double it again, then we'd get up to the 8. But we can do this mathematically as well. So we're starting off with 8 moles of aluminum. What's going to go on the bottom? Yeah, moles of aluminum. And what are we trying to find? We're trying to find how much aluminum bromide would be produced. So that could be moles of aluminum bromide. Okay. Now this is new. In the last chapter, we never had moles over moles, right? We would have moles over grams or moles over molecules or atoms, depending on what we're converting it to. But in this chapter, we're going to use a ratio here. And the ratio is based on the equation. So for example, with this one, moles of aluminum, if we're using this up here for our ratio, it's going to be 2 moles of aluminum. And then it's going to be 1 mole of the aluminum bromide. All right? And then we'll solve this to figure out how many moles of aluminum bromide you come up with. All right? So what cancels out here? The moles of aluminum. And then if you multiply the 8 across, multiply the 2 and the 1, you'll get 8 over 2, which simplifies into 4 moles of aluminum bromide. Okay? Is that cool? So that's mathematically the only new thing this chapter is doing this ratio based off of the equation, okay? And that's what's different from last chapter. Last chapter we were just dealing with one thing and converting it into something else. In this chapter we're going to take one thing and convert it into something else in the equation. Now, could you figure out the number of grams of this? Yeah, that was last chapter stuff, right? So we could convert these things into other substances as far as like the units go. So we could convert this into moles, or we can do molecules or atoms, any of that stuff. So we can still do that stuff. But the only new thing this chapter is this ratio. Okay, is everybody okay with that? Yeah?
How come it's Al2Br2 and not Al2Br6?
Oh, that was just a typo. Good catch. Al2Br6. Yeah, good. Anything else?